In this video, we're going to look at the Malonic ester synthesis reaction. This reaction is a little bit harder to see what's happening, but what you want to keep in mind is you're going to be converting an alkyl halide into a carboxylic acid, and that carboxylic acid is going to have 2 more carbons than the original alkyl halide. So if we think about what all that means, here's an alkyl halide. We'll talk about what the reagents and the steps are here in a minute. But in the end, what we're going to have is that R group attacks 2 more carbons, and that second carbon is the carboxylic acid. So R group from the alkyl halide, and then the rest of it is the standard coming from the reagents. You can add twice, and that second R group does not have to be the same as the first R group. So that is also possible. But again, the overall thing you want to keep in mind, alkyl halide converted to a carboxylic acid that has 2 more carbons than the original alkyl halide did. So the reagents we're going to be using with this, one of which is the malonic ester. And I'm going to draw this structure out for you so we can see what it looks like and why we're talking about it. So here's malonic ester, and the reason we're using it is we have 2 very acidic hydrogens here right in the middle of the structure. So we're going to be deprotonating and doing the alkylation of an enolate. So to do that deprotonation, we're going to be using sodium ethoxide. So that ethoxide will come in and deprotonate to form the enolate ion. Again, because we have the dual carbonyl, we don't need as strong of a base for that to happen. Now that we have our enolates, we'll do the SN2, so we need the alkyl halide. That carbanion will attack the carbon, pick off the halogen. We're forming the new bonds. At this point, we could add acid and heat, do a decarboxylation, and end up with our products. The byproducts are CO2 and 2 molecules of ethanol. So notice what is happening. I am breaking this bond, and I'm also getting rid of the ethyl group and protonating to make the carboxylic acid. So anytime you put an ester and acid, it's going to convert to the corresponding carboxylic acid. Instead of doing that step right away, I could add some more sodium ethoxide, remove the second alpha hydrogen, react with a second molecule of alkyl halide. Again, what's same or different does not matter. Now I have 2 R groups. Again, I can do the acid and heat and get my final products. This time I have 2 new R groups attached to that carboxylic acid. So just like we said before, we have our alkyl halide converted to a carboxylic acid, where we're adding in those 2 carbons that we did not originally have in the carboxylic acid. Those 2 carbons are coming from the malonic ester starting material. You can also make a cyclic product. So if you have a dihalide that has the halogens at least 4 carbons apart, this, instead of adding a second alkyl halide into the mix, it can essentially come around and react with itself and form a cyclic product. Let's look at a couple examples. So let's make this carboxylic acid using the malonic ester synthesis. So the thought process here should be, I know I'm going to get the carbonyl carbon and the next carbon over from the malonic ester. That means the rest of the molecule, so those 2 carbons and these 3 carbons, are going to come from the alkyl halides. I'm adding 2 R groups, so I'm going to have to do this process twice. It doesn't really matter which R group you add first. If you want to add the smaller one first to help the second step be a little bit more nucleophilic and less bulky, sure, but it's not really a big enough ordeal to make it matter. What we need to do is start with our malonic ester, which is commonly abbreviated this way if we're writing this in kind of reaction form here. So if you think back to the malonic ester structure and how it connects to this is a C, it's your middle carbon. So here's your middle carbon with your alpha of hydrogen and then the 2 ester groups on either side. So we'll start with that along with the first alkyl halide. I'll do the ethyl bromide first. I'll need sodium methoxide and ethanol. Then I'll add the second alkyl halide. And then last I will add the acid and heat, and that will give me the desired product. Let's look at a quick example. So let's prepare this carboxylic acid using the malonic ester synthesis. So just like before, we know the carbonyl carbon and the next carbon over come from the malonic ester. And then those are going to be the 2 bonds that I'm going to be forming. So if I notice, instead of 2 separate alkyl halides, I have a dihalide. So there's the dihalide. I will react it with the malonic ester. Sodium methoxide and ethanol, followed with the acidic workup and heat. I don't need to add in the second alkyl halide because it's already present from the original. So that reaction and conditions will give me the cyclic product.